right, so now this is the very last part of the unit. It's an absolute value inequality, and we had to do the compound inequalities before we got to this because before I even go over this, an absolute value inequality, um, absolute value inequality is just a compound inequality. So there are two different types of compound inequalities, right? We had the or and we had the and. And I made a video specifically for each of those two types of compound inequalities. And so you have to know which one is which when you're doing an absolute value inequality. And it's pretty simple. It's just if the absolute value symbol is on the left side, and once you get the absolute value symbol by itself, which I probably won't even, never mind. So once you get the absolute value symbol by itself, if it's on the left-hand side and you have greater than or equal to, so if you have this symbol or this symbol, it is and or compound inequality. So case one is greater than or equal to is an or compound inequality. If you have less than or equal to, it is an and compound inequality. So that is the key. You have to know which one you're doing first. So you have to know your symbols. So if you don't know your symbols, again, it would be these two are greater than or equal to. These two are less than or equal to. So if you're given the first one, this is a greater than or equal to. So we're going to have an or compound inequality. So that means at the end, it's going to be two arrows going out forever. And then if you have a less than or equal to, it's an and it's going to be shaded in between. So ands are shaded in between, ors are going out. Okay, so here's what we do. Again, anytime you have an absolute value inequality, I'll actually come back to this. So as long as we know which one is which so far. So the rules are a little bit different because remember when it comes to an absolute value equation, like if you had absolute value of x equals 7, there's two answers, right? You set up the positive case and then you set up the negative case. And so my two answers are positive 7 and negative 7. And so kind of the same is true for when you're doing an inequality, but there's one rule that's different. It says use the KISS method. Keep it, switch. So I don't know if that's going to help. I'll show you what that means in a second. Let's just go right into question one. And so I have my absolute value by itself, and my symbol is greater than. So if it's greater than, it's going to be an or compound inequality at the end. So I know that I'm going to be shaded to the left and to the right. And so here's what you do. You drop the inequality symbol and you set up x plus 6 greater than 7. You literally just copy it down without the inequality or without the absolute value symbol. Then your second one, because you're always going to have two cases, right? This is your positive case. So your negative case is a little bit different. And here's what you do. You do x plus 6, but you have to flip your symbol and make it a negative 7. So you have to flip your symbol and make it a negative 7. Notice that I only flip, like I just flipped my symbol. If it's a greater than, it becomes a less than. If it's a greater than or equal to, it would then become a less than or equal to. So you never add a line underneath, you just flip the direction of the symbol. Now I could set up, or now these are my two equations, and now I could solve them. So I would subtract 6, and I'm left with x is greater than 7 minus 6 is 1. I subtract 6, and I'm left with x is less than negative 13. So again, I know it's going to be an or because of the way it was written at the beginning. Greater than is always or. So this would be my answer. And so at negative 13, which would be all the way over here, I have an open circle and it's shaded that way because it's x is less than negative 13. And then at positive 1, which would be right here, I also have an open circle and it's shaded that way. So it's kind of weird how you set them up. You should first recognize that because it's greater than, it's an or. So I know I'm going to have an or in between, and I know my arrow is going to be shaded to the left and to the right. So my interval notation is negative infinity to negative 13 with a parenthesis, because a parenthesis means the same thing as an open circle. I have to put a union, and then I put 1 to infinity, both with parentheses again, because it's an open circle, and an infinity always has an open circle. So going um, back up to case 1 example and case 2 example. Um, the way we want to set this up is you're going to do x is greater than or equal to 7, right? You basically just copy it down exactly how you see it, but without the absolute value. Then you copy down the next one, but you flip the symbol and you make it negative 7. And again, this one is going to be or, because greater than or equal to is or. So it would look like this, where 7 is here. They're going to both have closed circles, and they're going to be shaded. There you go, shaded to the right. And then at negative 7, closed circle, shaded to the left, or always goes out like that. So the same thing is true for less than. Um, the only thing that's different is we know it's going to be an and. So at the end, we're going to shade in between the two numbers that we get. But how we set it up is exactly the same. So we forget the absolute value, we drop that, and we just copy down exactly how we see it, but without the absolute value. X is less than or equal to 4. Then we flip the symbol, and then we make it negative 4. So because it's less than from the beginning, I know it's going to be and I know it's going to be shaded in between. Make sure you flip your symbol and make it negative. And so at negative 4, I have a closed circle. At positive 4, I have a closed circle. And because it's and, I'm going to be shading in between. And that is the biggest part. If you don't remember anything, at least know how to set up your two inequalities and know which one is which. If it's greater than from the beginning, it's or. If it's less than or equal to, it's and. So for question 2, right away it's less than, so it's going to be and that means it's going to be shaded in between. And so I have to set up my two cases. My first case is just 2v minus 3 less than 19. You just simply copy down the inequality without the absolute value symbol. My second one is 2v minus 3. I change the direction and I make it negative 19. So then I go and I solve these equations. I add 3 to both sides, and I'm left with 2v equals 22. 19 plus 3, less than. Don't make that an equal sign. It's less than. You keep the same inequality symbol the whole time. Divide by 2. Divide by 2. V is less than 11. And then I add 3 over here. Add 3 over here. And I'm left with 2v greater than negative 19 plus 3 is negative 16. I divide by 2. I divide by 2. I don't have to flip my inequality symbol because I'm dividing by positive 2. I know there's a negative 16 on top, but we don't care about what is on the numerator. So I keep the greater than. I don't have to flip it. And then that equals negative 8. And so I know it's an and. So again, this is how you set up the actual answer. Instead of just writing and in between, that's not really the full correct way to do it. You look at your two numbers. We have 11 and we have negative 8. So negative 8 is smaller. So you start with a smaller number. I'm going to put it right here. And then I put the bigger number over here, which is 11. I put my variable in between, which is V. I always have these two symbols. They're always going in that direction. Then I just look back through. At 11, is there a line underneath? No, so I keep no line underneath. At -8, there's also not a line underneath the inequality symbol. So this would be my answer, which means it goes from -8 to 11, and it's shaded in between those two numbers. So at -8, I have an open circle. At 11, 10, 11 in between, 10 and 12, I have an open circle, and it's shaded in between those two numbers. And then my inequality, or excuse me, my interval notation is just you put your two numbers, -8 and 11, and then because they're both open circles, you have parentheses. So we did an or and we did an and. And so now what I'm going to do is I'm going to flip the page. Oh, actually, let's do question 4. Question 4 looks good. All right, so question 4. I have less than or equal to. So right away, less than or equal to tells me that I have an and inequality. So it's going to end up being an and compound inequality because I have a less than or equal to. So at the end, I know it's going to be shaded in between just like we did for question 2. So I do 7 minus 4n less than or equal to 27. My first inequality is probably the easiest to set up. I write it exactly the same, but I just drop the absolute value symbol. My second inequality is almost the same thing, but instead of having less than or equal to, I'm going to have greater than or equal to, and then I'm going to change it to -27. So I flip my symbol and I change it to a negative. Then I have to solve it. I subtract 7 first. I'm left with -4n less than or equal to 20. Now I'm going to divide by a negative. So because I'm dividing by a negative, my inequality symbol changes direction, and then that equals -5. So again, my symbol is changing direction because I'm dividing by a negative. Then I do the same thing over here. I subtract 7. I bring down the -4n. I bring down my inequality symbol. But this time, -27 minus 7 is -34. So it's a little bit, obviously you're going to get probably different answers because you're changing it to a negative on this side. And then now when I divide by -4, it's going to end up being a positive, but I have to flip my symbol because I'm dividing by a -4. So instead of being greater than or equal to, it's going to be less than or equal to. And then I don't believe that's going to work out nicely. So if you type it into your calculator, 34 divided by 4, it simplifies it to 17 over 2, which 17 over 2 is roughly, well, it's 8.5. So again, I'm going to have an and, right? That's what we decided at the beginning because it's less than or equal to. And so the way you write this, 17 over 2 is the same thing as 8.5. That's the bigger number. So 17.2, or excuse me, 17 over 2 goes on the right side. -5 goes on the left. I always put my variable in between. My inequality symbols always go in that direction. And then at -5, there's a line underneath it. And at 17 over 2, there's a line underneath it. So I start at -5 with a closed circle. And I go to 8.5, which is halfway between 8 and 9. And I shade in between because it's and. All right, so I'll do one more. It's going to be kind of a longer video. I will do let's do question 9. So question 9 on page 17 looks like this. Before you could determine if it's an and or if it's an or, you have to first get the absolute value by itself. Just like we were solving an absolute value equation, you have to isolate the absolute value. So I can't determine what it is just yet. I have to first subtract 7 and then divide by 6. So I have 6 times the absolute value of negative 5n greater than 37 minus 7 is 30. I divide by 6, and I'm left with negative 5n greater than 5. So because I didn't have to divide by a negative or multiply by a negative, my inequality symbol never changed directions. So now that my absolute value is by itself, and now that my inequality symbol, is greater than means or. So this is going to be an or inequality. I couldn't determine that from the beginning because if you look at like question 7, it's less than, so it looks like it's going to be an and. But when you divide by negative 10 to get the inequality isolated, you're left with, it flips the symbol because you're dividing by negative 10, and now it's actually an or because greater than means or. So once the absolute value is by itself, then you could look at your symbol and determine which one you have. You can't make that decision right away until you isolate the absolute value. So now this inequality, going back to this one, it's greater than, so it's or. So I set up my two inequalities. I have negative 5n greater than 5. That's my first one. My second one is negative 5n. I switch the symbol and I make it equal to negative 5. I divide by negative 5, divide by negative 5. Because I'm dividing by a negative, it flips the symbol. That equals negative 1. I'm going to have an or in between. I divide by negative 5. I'm going to flip my symbol again. It's going to equal positive 1 this time because the negative divided by negative is a positive. And again, I already determined that it's an or. So this is just your answer. It's this inequality or this inequality, which means it's going to be shaded to the left and then to the right. So at negative 1, I have an open circle, and it's going to be shaded to the left. And at positive 1, I have an open circle, and it's going to be shaded to the right.